Hello and welcome to Collecting Like Terms Lesson 3 Answers. So question number 1, 2x add 3y add 5x add 4y. And you might have done this question in 3 different ways. One, using counters. So 2x add 3y add 5x add 4y. Collect together the like terms. So I'm going to move these x's up here and these y's up here. There are no zero pairs on this occasion, and then sum, so that the total is 7x add 7y. You might have chosen to use a bar model instead, in which case you would have drawn out 2x, 3y, 5x, 4y, and then collect together your x's and your y's. I don't need these bars anymore because I've now moved those. Look for any zero pairs, and there aren't any, and then sum to get exactly the same answer. If you're not using either the counters or the bar model, then as a minimum, I would be expecting to see you use the commutative law to change the order of your sum so that you've collected your like terms together, and then that is identical to 7x add 7y. So, question 2. We have x add 2y add 2y add 4x. So x, 2y, 2y, 4x. Collect together the like terms. Look for zero pairs, and there aren't any, and then sum. You might have used the bar model as well, which is absolutely fine. If you used neither, then as a minimum, I should see in your books that you have reordered your sum using the commutative law, and then you have found your sum. Question 3. Three x add 5y subtract 2x, add 2y. So we need to think of this term here having a negative direction. So I'm going to think of it as being add negative 2x. So if I use counters, I'm going to have 3x, 5y, negative 2x, and then 2y. And so now when I collect my like terms, these are negative. So these x's and these negative x's are like terms, but I want these to be underneath the x's so that it makes it easier for me to find my zero pairs. These then can just join the end of that row. So these are zero pairs, and now I can sum to find that I've got x add 7y. Now, if you did that without either a bar model or counters, as a minimum, I would be expecting to see you use the commutative law to rewrite the sum. This direction needs to move with the term. You can't just move the 2x on its own. And so that is identical to x add 7y. Question 4. 6y add 7x subtract 3y subtract 2x. So again, I'm going to think of that as adding negative 3y and adding negative 2x. So 6y (7x) negative 3y, and negative 2x. And I'm now going to collect together my like terms, and these are negative, so I'm going to put those underneath to help me find my zero pairs. And then these are now underneath as well, so I don't need to move those. Look for zero pairs. Those are 0, and those are 0. And now sum what's left, 3y, add 5x. Now, there's nothing wrong with that as an answer, but typically you would see the terms given in alphabetical order. So this is identical to 5x add 3y, and that is a nicer answer than this one, although that is correct. So if you didn't use counters or a bar model, I would have expected to see you reordering using the commutative law. You might, in that case, have put your x's first, but something like that, 3y, add 5x, and then just changing that order so that it's in alphabetical order. Okay, question 5. Is negative 3y, add 5y, add 7x, subtract 3x. So this sign belongs to this term. It's the direction of this term. And I'm going to think of this as add negative 3x. So again, this is the direction of this term. So I have got negative 3y plus 5y plus 7x negative 3x. And actually, I don't need to reorder anything here at all, because in my calculation originally, the y's were grouped together and the x's were grouped together. So now I just need to look for my zero pairs, which are there and there. And now I can sum to find 2y add 4x. And again, I would rather have that in alphabetical order. So that is equivalent to 4x add 2y. If you didn't use counters or a bar model, you wouldn't have needed to do anything with the commutative law here, because actually they are already grouped together. So you could have gone straight from this to this answer, but then it would have been nice if you had changed the order so that they were in alphabetical order. Okay, question 6 is the first question that introduces some constants. So question 6 is 2x, add 5, add 3x, subtract 4x, add 6, subtract 2y. So again, I'm going to think of this as add negative 4x and add negative 2y. So I have got 2x plus 5 add 3x, add negative 4x, add 6, add negative 2y. And I'm going to collect together my like terms. So I have got positive x's here that can join the end of this row. I'm going to move these down for the moment so that I can move my negative x's up. These are all positives as well, so they can join this row. And then I've got these. Look for zero pairs, and these 4 are all zero pairs. And then sum what remains, and that is going to give me x, add 11, add negative 2y. And typically what you see is that constants go at the end. So I'm going to write this as x. It's identical to x minus 2y, add 11. If you didn't use the counters to answer that question, then I would have been expecting you to reorder this so that it was 2x, add 3x, add negative 4x, add 5, add 6, add negative 2y. And then you can sum these first if you like, and then find your zero pairs, but that's going to give you x plus 11 plus minus 2y, and that's essentially your correct answer, but it would be nice then if you reordered those. Okay, question 7 is 10, add 9x, subtract 4y, add 8y, subtract 6x, subtract 12. So I'm going to think of this as add negative 4y and add negative 6x and add negative 12. So 10 across the top, then 9x, then negative 4y, then 8y, then negative 6x, and then negative 12, okay, so now I'm going to collect together my like terms. I'm going to, it's a bit difficult to do this by shuffling them around in this space. So I'm going to pick them up and I'm going to pick up these negative 12 from the bottom, because I think the easiest thing to do is to move those to the top and then move these x's down here, because then I've got everything collected together. So these are all going to sit underneath the positive ones so that I can see my zero pairs. And now I can look for my zero pairs. So all of these are creating zero pairs. So all of these at the top, positive 10, I'm going to lose along with 10 of the negatives. And that's going to leave me with just negative 2. And then the negative 4y is making zero pairs with 4 of the positive y's. So those are all 0. And the negative 6x is making zero pairs with 6 of the positive x's. And so in the end, I'm left with negative 2, add 4y, add 3x. But I would like to see that in alphabetical order with the constants at the end. So again, if you did that without counters, what I'd be expecting to see is that you have used the commutative law to rewrite your calculation, and then you've worked out your sum. And then you should also have written them in alphabetical order with constants at the end. Okay, question 8. Negative 12x, subtract 8, subtract 10y, subtract 7x, add 8y, add 2. So I think I'm going to go through this one just by using the commutative law on this occasion. So I'm going to put brackets around this to say that that is the direction of this term. And I'm going to think of that as add negative 8, add negative 10y, add negative 7y. And so using the commutative law, that is identical to negative 12x, add negative 7x, add negative 10y, add 8y, add negative 8, add 2. So I've grouped together my like terms, and now I can find my sum. So here, negative 12x plus negative 7x gives me negative 19x. And then negative 10y add 8y, that will give me negative 2y. And then negative 8 add 2 will give me negative 6. And I can write that as negative 19x, subtract 2y, subtract 6. Question 9 and 10 are a little different because they are decimals and fractions, which makes it a little bit more challenging. So question 9, 12.5x, take 7.2x, add 3y, subtract 2.7y, add 5.6. So I'm going to think of this as add negative 7.2x, add negative 2.7y. And actually I don't need to reorder that using the commutative law because the x's and the y's already are grouped together. So 12.5x add negative 7.2x, that gives me 5.3x. 3y add negative 2.7y gives me 0.3y, and then my constant at the end, there is no other constant, so nothing to add or subtract from it, so it's just as it was, add 5.6. Question 10, we've got a tenth plus a half x plus a third y plus a quarter x plus a third y minus a fifth. So I'm going to think of this as plus minus a fifth, and then I'm going to reorder to collect together my like terms. So I've collected together my constants, and then my x's, and then my y's. So I have got 1/10 add minus 1/5. Well, I know that 1/5 is the same as 2/10. So I'm going to change that there. I know that a half of x is the same as 2/4 of x. So now I can work all of this out. 1/10 add minus 2/10, that is minus 1/10. 2/4 of x plus 1/4 of x is 3/4 of x, and then 1/3 y plus 1/3 y is 2/3 of y. Now, if you struggled with that question, or even if you didn't get as far as doing that question, or even question 9, don't worry about those because these were there as the challenge, particularly this one. We haven't done fractions yet this year, and we will be doing that shortly. So hopefully in a few months' time, this will be no problem for you. But at the moment, it's a little bit tricky.